Okay, we're going to continue with our notes about angles and circles. But now we have to decide what to do if it's not a central or an inscribed angle. So let's first look at your angle and circles formula sheet. We know it's an inscribed angle when it's formed by two chords, and we know then the angle is half of the arc. Well, the angle is still going to be half of the arc as long as the vertex is on the circle. And in this case, the angle is still going to be half of the intercepted arc. But this time, this angle is not created by two chords, it's created by one chord and a tangent. But because the vertex still has the same location, we still have the same formula. Okay, let's look if the vertex could be somewhere else. Here the vertex is inside the circle. And now when the angle stretches out, we've got two arcs. Okay? So this is formed by two chords that are intersecting. Okay? And in this time, now that I've got two arcs that I need to deal with, this time it's going to be half the sum of the two arcs. So we're basically averaging the two arcs. Now, remember vertical angles, the left and right angle are the same, so it doesn't really matter which one you're solving for. And if you wanted the top angle up here or the bottom one down here, you could get it by using those top and bottom arcs. And you'll see some examples of that in a minute. Alright, well what if the vertex is outside of the circle? Here it's outside of the circle and it's formed by two secants. Here it's outside of the circle and it's formed by a tangent and a secant. Here it's outside of the circle and it's formed by two tangents. But it doesn't matter where what it's formed by. The fact of the matter is the vertex is outside of the circle. So you have three things you're dealing with. The angle that's right next to the vertex. Here's the angle. And then you're going to have a small arc. And the small arc is the arc closest to the angle. Small arc. And then you're going to have a big arc. And the big arc is clearly bigger and it's furthest away from the angle. This one, here's your big arc here. Alright, so you've got two arcs that you have to deal with, but this time, instead of adding together, you're going to subtract, and for it to come out positive, you're going to take 1/2 the big arc minus the small arc. Alright, now that we have all the formulas, let's go back and try and solve some of the problems. Alright, example 1. The vertex is right here on the circle. So when it's on the circle, and this 1 is saying angle 1, not 1 degree, this angle, the measure of angle 1, equals to 1/2. Well, when it's on the circle, it's half of the intercepted arc, which is 150. That's just going to be 75 degrees. Okay? Even when the equations are simple, if you make yourself set them up, you're going to be better off. Here, the vertex is outside of the circle, so the measure of the angle, you always say the measure of the angle equals. Well, when it's outside, it's 1/2, and then we subtract the two arcs. Well, clearly 100 is bigger, and the bigger arc is always going to be further from it. So we have 1/2 of 40, which is 20. Alright, let's look at some more examples. Example 3. The vertex is inside the circle, inside anywhere but the center. So here, the measure of angle 1 equals 1/2. Well, when it's inside, we're dealing with two intercepted arcs. And when it's inside, we're averaging them, so we're just adding them together and dividing by 2. So we have 1/2 of 122, which would just be 61. Okay, let's look at example 4. The vertex is on the circle. When it's on the circle, the angle, which is 5x, the angle is always closest to the vertex, and you always write the angle equals, followed by something else. Well, it's going to be 1/2 of the intercepted arc, and the intercepted arc is 9x plus 20. We've done this before. Get rid of the 1/2. Multiply both sides by 2, leaving you with 10x equals 9x plus 20, so x equals 20. Alright, more examples. Example 5, the vertex is inside the circle. So when it's inside the circle, the angle, which is 80, the angle is always the one closest to the vertex. The angle equals, and when it's inside, it's the average of the two arcs. So it's 1/2 of 120 plus x. And when you're adding, the order doesn't matter. Multiply both sides by 2. So I get 160 equals 120 plus x. So 40 equals x. Alright, let's look at example 6. The vertex is outside of the circle. So when it's outside of the circle, the angle, which is the one closest to the vertex, the angle equals 1/2. And when it's outside, it's the big arc minus the small. Pretend these are touching. Okay, so here is the small arc. So that's minus 80. But what you weren't given is this arc right here, which is the big arc. But we know all the arcs in a circle add to 180. So if we take 360 minus 80, we get 280. So the big arc is 280. Now we can finish the problem. 280 minus 80 is 200, and half of that is 100 degrees. Okay, so remember this. To get that big arc, we took 360 minus 80. Alright, now let's try this one. The vertex, it's outside the circle. So the angle, this is the angle, it's the one closest to the vertex. Oops, I wrote angle, not 60. Just kidding. Okay, 60 equals 1/2, and it's always the big arc minus the small arc. Well, the small arc is given to you. This is the small one, right? That's x. The big arc is this whole thing right here. Well, last time to get the big arc, we just did 360 minus the small arc, right? And the small arc is x. So the big arc is 360 minus x. So yes, you get two x's there. So now we have 60 equals 1/2 times 360 minus 2x. So 60 equals 180 minus x. You can clear the fractions, but on this one you might as well just multiply by 1/2. Okay, so I get negative 120 equals negative x. So x is 120. And we're done. Okay, let's look at example 8. The vertex is outside of the circle. So when it's outside of the circle, the angle, which is x, is 1/2, and it's always the big minus the small. Well, here are my two intercepted arcs. This is the small, so this one's got to be the big. So the big is obviously 120, but we're missing the small one. Can we find it? Yes, of course we can, because all the arcs in a circle add to 360. So 360 minus 100 minus 120 minus 100 gives us 40. So this is 40. Alright, simplify. 120 minus 40 is 80. So x, just kidding, x is 40. Let's try some more examples. Example 9. Okay, again, the vertex is outside of the circle. So when it's outside of the circle, the angle, which is the one closest, is 32, equals 1/2 of the big arc minus the small arc. So I gave you the big arc, that's 124, minus the small, that's x. Multiply both sides by 2. That leaves you with 64 equals 124 minus x. So take 64 and subtract 124, and we get negative 60 equals x. So x, excuse me, negative x, so x is positive 60. Okay, example 10. The vertex is inside the circle. So when it's inside the circle, it expands out, and these are the two intercepted arcs. So the angle, which is x, equals 1/2, and when it's inside, it's the sum of the two arcs. Well, one is 68, but we don't know the other one. Can we find it? Yes, we can, because all the arcs in a circle have to add to 360. So 360 minus 92 minus 68 minus 112 gives us 88. So this is 88. So here's 88. So simplify. 1/2, 68 plus 88 is 156. Half of 156 is 78. So we get 78. All right. I want you to try example 12 on your own. So pause the video and then check your answer. Okay, hopefully you got x is 98. All right, let's look at this one. Example 12. Vertex is inside the circle. So when it's inside the circle, the angle, which is 44, equals 1/2 the average of the two arcs. Okay, so one arc is x. The other arc we don't know. We can look and see that this is a diameter. So that means that this together is 180. So 180 minus 70, or excuse me, 180 minus 102 is 78. So we know this other arc is 78. And now we can solve the problem. So I'm going to multiply both sides by 2. That cancels. So then I get 88 equals x plus 78, so x is 10. Alright, try example 13 and 14 on your own. You've done enough of these, you should be able to. Okay, on example 13, the vertex was on the circle, so it's half of this intercepted arc. And so you have to do 360 minus 236 to find the intercepted arc. On example 14, the vertex is outside the circle, so it's 1/2 the big arc minus the small arc. Okay, last example. This has got a lot going on, and I'm going to go through it quickly, so just pay attention. Here we go. First, they want BEC. BEC is formed by two radii. Its vertex is on the center. It's a central angle, so the angle's got to measure the arc. This is 62. Then they want BAC. Well, if I'm looking at BAC, it's formed by two chords, and its vertex is on the circle, so it's a central angle, so this angle is going to be half of the intercepted arc. So half of 62, would be 31. Now they want arc AB. Well, it finishes off the diameter, so 180 minus 62 would be 118. So this is 118 here. Okay, BCA. BCA. Well, if I'm looking at BCA, BCA is formed by two chords, and its vertex is on the circle, so it's an inscribed angle. So this angle is going to be half of its intercepted arc. So it's going to be half of 118. And half of 118 is 59. Okay, now they want ABC. ABC is this angle right here. Well, it's formed by two chords, so it's going to be half of its intercepted arc. So it's going to be half of 180, so it is 90. Now they want, oh, there's two ABCs, that's not a word. They want EBC, this angle right here. Well, that's a little trickier, but if you remember, in a circle, all the radii are congruent, so these are equal. So that means this is an isosceles triangle. So if this is 59, this has got to be 59 as well. All right, now they want arc DC. Okay, arc DC. Well, if the only angle that goes with it is this one, and so it is an inscribed angle, so this angle, which is 44, is going to be half